how do you factors in the blockchain technology itself, in which you will be able to authenticate whether the miner is a authentic, genuine miner or not. First one, right? What does a miner do? Basically, the miner will create a block, right? Now, what does a block contain? A block contains a series of transactions, right? So each transaction is validated by the initiator and is broadcasted to everyone in the network. So if there is any transactions in the network, then in that case, everyone should have access or should be aware of the transactions down, or when someone comes joins the network anew, right? So let's just park that these two scenarios aside for a bit. But then let's say that everyone is there in the network, the transactions are broadcasted, so everyone is aware of the transaction because the transaction is already verified, so it gets broadcasted, so everyone are aware of the transactions which are there in the network, which have not been committed. When I say which has not been committed, which has not entered into the blockchain, right? So that way, that's one, right? So you verify whether the transactions in the block are basically the genuine transactions which you have received or not, right? So that's the first way of one way of ensuring that whatever transactions are there in the blockchain are not corrupt or not fake, right? Now, second, right? So basically what happens is the concept of mining is to increase the complexity so that no hack the block easily, right? So that's what we'll talk about it in a bit. But basically there is something called as blockchain complexity, and the miners on how secure your blockchain is based on the complexity of mining, right? And that's where Bitcoin, if you look at it, it requires dedicated hardware and specialized algorithms to mine a particular block. The faster you mine, the more reward you have, right? So let's now say that there is a fake miner and who has basically say he has as the miner all the fake transactions, and he has created the transactions. Now what happens is there is I'll talk about the concept of chaining, right? So where every block has a hash associated with of the previous block, right? So one, the longer, the more secure or safe the transactions are, right? So that is another way in which, because you're increasing the complexity of mining, so your blocks cannot be easily replicated, and that's another deterrent for fake miners, right? The third one is the consensus algorithm, right? Where uh, once a block is broadcasted, right, everyone will validate the hashing. I'll talk about the hashing part of it, how they validate the blockchain. And then when you're adding or committing a block, right, so one, you need to have the previous block, and only the longest chain will get accepted as part of your blockchain, right? So again, we'll talk about it in detail when you see the actual implementations. So these are the three ways in which you're enabling trust. One is the transaction signatures per se. Second one is the complexity of the block. Then the third one is the longevity of the block. So these are the three ways in which we deter fake miners becoming part of the blockchain, right? Or fake transaction entering into the blockchain. We'll take a look about it in little more detail. Hope that clarifies or answers your question, madam.
Yes, sir. Thank you, sir.
So probably let's take a look at the block, right? So as I said, a block is nothing but a series of transactions. A blockchain contains a series of transactions. It could be one transaction from the same, it could be 100 transactions from the same user, or one transactions from 100 users, right? So there are nodes, like I said, which validates these transactions, will ensure that the right keys are used and they're authorized, and that is what your smart contract applications in the blockchain network will do. Basically, they will validate whether the right person is authorized for this particular type of transactions, and he has the right checks and balances. Like, for example, in Bitcoin, whether you have the right amount of money to debit from your account, etc., broadcasted to the blockchain network, right? So every node in every miner in the network will be receiving or listening for these transactions, and then what they will is they'll queue these transactions in their cache, and then they will club all of them together, because it's very time consuming and will not be cost effective if the block contains very few transactions, or if a block contains large transactions. So your blockchain technology will decide on, or your blockchain application domain will decide how many number of transactions you need to store within a block. So again, it depends on the cost, frequency, the speed at which you need to confirm these transactions, etc. Right? So let's say the miner basically identifies the block. We'll talk about the complexity of a block in a bit. So let's say that a miner generates a block with the first 10 transactions he has received, and he generates a block with the right hash value. And then what he will do is then he will broadcast. Basically, when I say the hash value, it's nothing but whatever the blocks he's aware of, the latest block which he's aware of, he'll put the hash value of that block, and then he will create a hash value of the new block, now meeting the complexity requirement. Once he has found the new block, the miner has created the new block, it will then get broadcasted to the network, so that now the network will then validate whether this new block is valid or not, right? So in private and in community networks, they will also use the identity of the miner to validate it. But in a public domain, they will use which is the previous block here's the miner this block contains, right? Whether the hash complexity of the hashes conditions are met, whether the transactions in the block are validated or verified ones. So these are the three things which everyone in the network will look for, and they will commit, right? Once they commit, they will start broadcasting that they have acknowledged these new block as the latest block, right? So that's how the blockchain works, and that probably also answers the previous question which was raised, right? Hope that clarifies. If there are no questions, then probably I can just go into the introductions of the hashing algorithms, signatures. In each of these three aspects, we can talk about how it is implemented. Okay. Let's look at hashing, right? So all of you are aware of hashes, right? So basically what hash does is it takes n number of n variable input. So basically your input message could be any length, and it translates into a fixed length. Like if we talk about 256 byte hashing, then if you give any variable length messages, it will always convert it into a 256 bit value, right? And the function of hashing is such a way that once you have hashed it, no two messages, right? Even if there is a small delta, a very small increment, no two messages will be hashed to the same value, right? That's first one property. And the second property is that you will, from the hash value, you will not be able to get back your message, right? So that's what it is. So basically the hash function is basically it's collision free. That means that no two messages will give you the same hash output, and basically it's hiding. When I say hiding, it means that your messages cannot be retrieved, your original message cannot be retrieved from the hash value, right? So I think this is a simple 256 SHA 256 is a common hashing functions which is used. So basically what it does is it takes it breaks the block into a smaller size, and it has the initial key, and then it keeps basically performing an operations, and then if the message is less than the 512 bits, then it will do a padding, so so that there are uniform number, and then you'll get a 256-bit hash values, right? Now, coming to the security part of it, or what a blockchain actually means, is that basically what it does is, uh, uh, usually in blockchain, we use a concept of hash pointer. Hash pointer is nothing but it has a value, right, or a checksum of the data. And then sometimes you could also have the data inbuilt within the block, right? So we'll talk about it in a bit. So let's say you have a data. So then what it will do is it will have a pointer to the data, and then it will have the hash value of this entire data, right? So now if you do any changes in the data, your hash value will change, right? So that's the concept you need to remember. So in a blockchain, so what you typically do is you have the first block, which is usually called as Genesis block, right? So that is reserved, or it is created magically outside of the blockchain and entered into the network. So once you have the Genesis block, right? So then your first block, which you will create, will have a pointer to this first Genesis block, right? Hash of this block, right? And then the new transactions, right? So now if a malicious, let's say we talk about a malicious miner who wants to tamper this data, right? So let's say he wants to modify the data which is in block 0, then if he modifies and he sends an alternate block 1, then basically what happens is the hash value of block 0 would be different in his block. Hence, the network will say that, okay, he's referring to a wrong chain, and hence they will discard, because they're not looking at that chain. So they might discard that particular block, right? So that is how a chain is maintained, and basically a protections or trust is established. Right now, the other concept I mentioned was immutability. So when I talked about immutability, once you have done a particular operation, let's say you have made a transaction in block 1, right? Once you have made this particular operations, you cannot modify it, because the moment you modify it, your block 2 also will need to be modified, because the hash value of block 1 would have changed. And now since block 2 would have to be modified, then even block 3 needs to be changed, etc. So the chain goes on. So that is where in blockchain, immutability is achieved through this concept of a blockchain, where once you have initiated the transactions, these transactions cannot be modified, but it can only be appended. So if you have done, let's say you have credited, you have 100 rupees, let's say your Genesis block says that you have 100 rupees in your account, right? Now you have transferred from your account to some other account, let's say 50 rupees, right? Now, at this block 1, your transaction, it says that you have only 50 rupees. Now, when you have to further say that, okay, now I have given 50 rupees to person B, but now instead of 75, I've only given 50. So in that case, what you will do is you will either create another transaction in the new block, where you will give him the additional 25 rupees, right? Or let's say that you have to pay him only 40 rupees, but you have made a transaction of 50 rupees here in block 1. So in this case, then what you will do is you will request the other person to initiate a transaction back, where he will credit 10 rupees back into your account, right? So that will be your new transactions in block 2. So that is where what we are saying is, once you have made a transactions, once you have committed it, you can never change the data. And this is what the immutability is achieved basically through hash pointers or the SHA algorithms, right? Any questions so far? Hope this concept is clear, because this is one of the key concepts, and we will look at it. We will, there are already in Python, there are ready-made SHA 256-bit algorithms. So we'll use one of the libraries and see how we can code it, right? Now, Let's talk about the other question which Madam asked was in terms of, I think when I was explaining, I talked about the complexity of the block, right? So because if you look at it, when I said that the hash value of the block changes, right? And that is very difficult for us to generate this hash value. So what is so specific about the hash value, right? Now, if you look at the hash value, so basically one of the complexity of the network would depend on the uh, will depend on the basically what they typically call it as the leading zeros in the hash value. So basically in most of the network, let's talk about the bitcoins, right? In bitcoins, you need to generate a nonce, right? Nonce is a unique value which the miner has to identify such a way that the hash value will have the first 4 digits or first 7 digits as zeros, right? So that is where what the miner does. So basically what the miner will do is if he if the miner node has received these let's say these 5 transactions, right, and this is the previous hash which is the latest block of in that blockchain network. So what it will do is basically it will try to find a hash, because if I just do a hash of the transactions and the previous hash, then it may not achieve it will not, the hash value will not have the first 4 digits as zero. Let's say that's the complexity which we have identified. So basically what the miner will do is it will add this nonce value where it will just start from zero, the nonce value, and it will keep on incrementing it such a way that uh, the first 4 digits of the hash, which the new hash which gets generated, contains the first four digit contains zero value, right? So this is what the complexities are, and this is where if you look at the different algorithms. So bitcoins is using 7 zeros, starting with 7 zeros, the hash value, and then similarly other blockchains will reduce. The moment I reduce the number of zeros, trailing leading zeros in the hash value, the complexity and the faster I'll be able to identify a nonce which will generate me that hash value, right? So basically one of the biggest disadvantages of blockchain is the time it takes to confirm a transactions, right? The higher the complexity of the hash values are, the larger the time it takes. And that's where if you look at it in private network or in hybrid blockchain, they will reduce this complexity to say, let's say they will say that 2 zeros instead of 4 zeros, and they will have another identity of the miner node, so that they will say that whether this person is authorized at that point of time when that node was able to generate the block, right? So that is the way in which you also validate. So when you generate a block, you need to generate a block which has these first 4 values as zeros, right? And it's time consuming. So whoever gets the first, whoever are able to generate this hash value faster, that block will get accepted in the network, right? And when this block gets broadcasted, what they do is they verify the transactions, they verify the previous hash, and they verify whether the new block's hash meets the toughness or the difficulty of that blockchain network. So that's how trust is established, right? So hope that clarifies. So now let's jump into the code. So like I said, we'll first talk about hashing part of it. So I have used the hashlib. It's always better to use existing libraries. So I think, as I said, we will just create a block structure which will contain the index. Index is nothing but your block number, right? Block number is sequential. It's basically an incremental value. So basically, always you can assume that the block number will have the last block will have the largest number in the blockchain, right? So this is another way in which you can identify whether you're working with the latest chain, or whether you missed any transactions when you rejoin the network, right? So basically, let's say that you start with block index 1. Then like I said, you'll also have a timestamp. Let's say a transaction, in this case I've just kept it as a string, hello, and then let's talk about the proof. Proof is nothing but your nonce value, which I mentioned here, where we are just given some random value, and the previous hash, like I mentioned here, it's basically the hash of the either the genesis block or the latest transaction block, right? So that's just what it is. So basically we are just encoding. This is a structure. So what we are doing here is we are encoding that into a series of bytes, and then we are generating a hash value of that particular bytes which we have encoded from the structure, right? So that's another that's an example of how we generate the hash. We'll look at the complexity part of it. I'll show you the algorithms to check how our complexities are managed. Okay. Now, the other concept in blockchain is digital signatures, right? We know that there are symmetric signatures and asymmetric signatures. So basically what blockchain does is basically uses the asymmetric signatures. We'll talk about what it is. So basically cryptography or encryption is where your messages are encrypted, and only you will know that. So basically what will happen is you'll have a key, right? So let's talk about a symmetric key, where each of us would have a unique key. And then what we will do is, let's say magically we share our keys with our friends or the people whom we trust. Then whatever message you encrypt, they can use the key which you have shared with them to decrypt your message, because they know what your identity is and they'll be able to send it out. Now, this is the challenge here. The biggest challenge with symmetric key is how will you share, what is the mode in which you will share your private keys or your keys for decrypting to each of these individuals in the network, right? So that's the biggest challenge. And that's where the concept of asymmetric key comes in. In an asymmetric key, what you'll have is you will use your private key to encrypt the data, but then everyone in the network will have your public key. So you can broadcast your public key, and then everyone will be able to use your public key and decrypt the message and say that, yes, this person, this is a valid message, or this is a genuine message, right? So that is what your encryption does. Like I said, whenever you have what you do is when you join a network, you will generate two keys. One is your private key or the secret key, and the second one is the public key. Public key is only used to verify that that message which you have sent is not tampered, right? So that's what the public key is there, and public key is broadcasted or distributed to everyone. So everyone, if they have your public key, they will be able to verify you any message which you send using your private key. So that's what it is. So basically what you do is you send a signature using your private key and the message, and then what they will do is they will have the message, they'll have your signature, and they'll use the private key to verify that whether the message has been tampered or not, right? So that is the basically the idea here is, if you have initiated a transactions in blockchain, let's say you have debiting rupees 10 to your friend's account, right? In that case, what you will do is you'll use your signature and you will say that my transaction is to transfer 10 rupees from my account to account B, right? So that message gets signed or signed, and then you send the signature along with the message. Now when anyone in the network, because they know your public key, they will validate, because they know that you're sending the message, they will pick up your public key, they have the message, they have the signature, and they verify whether someone has tampered the message or not, right? So that is what basically public private key does, and this is what blockchain uses for identifying individuals and ensuring that the transactions in each of these initiated by each of these individuals are valid transactions, right? Hope this concept is clear. So like I said, usually the private key is a random 256 value, and the algorithms are usually the ECC algorithms. And basically, whenever you generate, you apply using the private key, you get the hash value of um, that. That message, and then you can use your public key to validate if that hash value is correct or not. Right. So that's what it is. So let's go to the next concept. I think I'll skip these, right? So as I said, let's look at how we are establishing or enabling trust, right, in a network. Like I said, you initiate a transactions. The transactions are verified using your signatures, right? Your public key or private key, etc. You're to ensure that you're authorized. One, you're authorized to do that operations, and two, your operation is not tampered, right? So that's what we do using the digital signature. Once it is validated, if the message is corrupted, or if someone is forging your signature, then that will get rejected. So let's say that your transaction is validated. So what the node does, right, in the blockchain is it will collect all validated transactions, right? But it will just collect it. It has not yet created a block, or it is not yet entered into the block, right? Now it will have a set of transactions, and then what happens is these set of transactions will now then once it reaches a threshold, let's say you said that every block contains a minimum of 10 transactions, or within a timeout period of 1 minute, right? So in that case, the miner will start working the proof of work. Basically, what I mentioned is they will start identifying the nonce value, and then once the nonce is identified, they will broadcast, and they will send it to everyone in the network, and then everyone in the network will validate whether the previous hash value, the new hash value, meets the requirements of the blockchain. And then once it is validated, it gets added to the network. And once, depending on the consensus algorithm, let's say the majority of them have agreed, then that latest block will become part of the block. Right. So I think, like I mentioned, let's say you have a malicious block which gets added over a period of time. This chain will get dropped, because this will be a smaller chain compared to the bigger chain. So the concept in the blockchain is always the longer chain wins the trust. Right. So that's what the blockchain is all about. Like I said, different algorithms, the different blockchain implementations or technologies for computing the difficulties of the hash, right? The Bitcoin is the simplest one, where it just needs to compute the nonce value so that the first 4 or 7 digits are zeros. But then we spoke about proof of stake, because this delays the time it takes to compute this hash value, or compute the mine, create a new mine, is very difficult, or it's very time consuming. So that's where the number of blocks, that the time it takes to commit a transactions to a block, is very slow, right? Like for example, if you talk about your phone pay or UPI or any of those transactions, right, it hardly takes less than a second for those transactions to be verified, because there is a central entity which is validating and authenticating and doing the establishing the trust for you. Whereas in the blockchain, because there is it's a distributed, no central entity is there, it's a distributed network. So that's where, because everyone needs to trust that this person or this transaction is genuine, it takes more time, and hence the number of transactions, the speed at which the number of transactions gets confirmed is less. And that's where there are other algorithms like proof of stake, like I mentioned, usually in a community or in a private network. The miners are identified, and they're authorized to generate a certain percentage of new blocks, or they're authorized to create mines at a particular time, etc. Right? So that's where, if you look at most of the different varieties of blockchain technologies or algorithms, it all depends on the consensus protocol and the difficulties of your hatching. So that's what the different technologies are, right? So now let's take a look at how basically we can create the block, right? So let's look at it. Like I said, we saw the definition of the block, right? We talked about the block number. We talked about the timestamp so that they know that the block when the new block is created, the latest, the older one or the older timestamp gets preference compared to the latest one. And then you have a set of transactions. Transactions are nothing but your message. So in the previous slide, I just put an hello message. So that's now I've just called it as messages here. So basically here I have the sender identity, basically the public key of the sender, the recipient, right? So basically the public key of the recipient, the transactions, right? It could be, there are multiple ways in which your transactions can be represented. So let's say that we are just debiting 5 here. +5 means that sender is sending to recipient, -5 means sender is receiving from the recipient. Let's just assume that thing. So basically, like I said, you can see in Python, the square brackets means it's an array, right? And basically curly brackets means it's a dictionary. Basically, it's one set of record, right? So you can have n number of such transactions in a block, right? And then we talked about proof. Proof is nothing but the nonce value, which will ensure that your hash value has the first 4 digits as 0. Previous hash is just, I've just put a random number here. Basically, previous hash is the hash value of the previous block, right? So in this case, this could be a Genesis block because your index value is 1, right? Now, basically, let's talk about when you have to, what we need to do when you have to create a new block, right? So basically what you'll do is when you have to create a new block, what you'll do is you'll increment the index. Like I said, you will take the index value of the latest block and add 1, right? So that way you know that whether you're working on the latest block or you're working on something wrong, right? Then we talked about timestamp. Timestamp is your current time. Transactions is basically whatever the unconfirmed transactions you have received. That's what you will add into the transactions. Proof, we'll talk about the proof. Basically, proof is basically the nonce value, which will ensure that you have your hash value meets the complexities which is required, right? Previous hash is nothing but the hash value of the last block which you have in your this one, right? So once you have created a new block, then what you'll do is you will flush out your transactions, right? The current transactions, you will make them null because your current transactions have now become part of this new block, right? And then what you'll do is you will append this block into your chain, right? So that's what, when you do a new block, what it is doing is you get the proof value. We're assuming that somehow you have computed the nonce value and you are given a chain, right? You're giving the latest block in the chain. And then you will also have the previous hash, basically, which is nothing but the latest block values, hash value, which has been computed. So that's what you take, and then you generate, basically, where you put your transactions into the block, right? Have the right nonce value, and then basically return the new latest block. So that is what this is, a definition or a function, if you have to call, if people are familiar in a functional programming language. So basically, this is nothing but a function when you, how you create a new block, right? So for creating a new block, what is very, very key is proof, which is nothing but your nonce value, to ensure that your hash of this new block meets the requirement of your complexity, right? Basically, like I mentioned, the first 4 zeros, etc., right? And self is nothing but you should always have the latest block in that blockchain network, so that you're basically, so you know that you're working on the latest block. So usually most of the time the miners' efforts gets wasted because they might either be working on an older block because they might have been out on the network outside, where they might not have received the new blocks or the new additions to it, or they would be too slow in computing the proofs. These are the 2 reasons why the miners might fail, or usually the success of mining is usually very, very low, and it decreases exponentially as time goes on. Now, we saw how to create a new block. So let's look at new transactions, right? I've not, for the purpose of simplicity, I have not put any code for validating whether it is the actual genuine sender or recipient, or even I've not just made whether the sender has the right amount balance in their account, right? So just let's assume that it's a very simple, someone has authorized, or basically the applications have taken care of this logic of validating the sender, validating the recipient, and validating whether the amount, whether there is enough balance to debit that particular amount, right? So basically what we will do is, let's just say, since we said that the transactions will have a sender, recipient, and an amount, we take these three as the input value for this function, and then basically append it to the last set of current, basically append it to the current set of transactions, and basically return that, saying that this transaction was initiated for this particular block. So that's what we are returning, right? We spoke about the hash algorithm. So very straightforward. It takes the block, right? It takes the block and then it encodes it into a common string, a series of bytes, and then we use the SHA-256 to return the hash value of this particular block, right? So that's what it is. So basically, last block will give you the latest value. I think in Python, if all of you are familiar, -1 means it will return the last value in that array. So that's how we are just getting the last block, right? Now, let's say how we can find the hash value to the nonce value to meet a particular set of this complexities, right? So so let's say that your X value, let's say X is the message, right, which you want to encode, and basically Y is the nonce value. So we are starting with 0. So what you do is you take that block, whatever the hash value of that block is, and then you encode it such a way that you will check if the last 4 digits are zeros, right? If it is not 0, then what you do is you increment Y to 1, and then again redo that exercise continuously until you find a value of Y such a way that you meet your difficulty, right? So that is what this difficulty is, and this is what your miner does. Of course, this is a very simplistic representations. There people have written an optimized algorithms so that they're able to identify the nonce value more faster and quicker, right? So basically here Y is nothing but your nonce and X is nothing but your message. So that's what we are trying to do here. So we will call this function as proof of work. So basically what it does is it validates whether the new proof value, basically it starts with proof 0, and basically the last proof is nothing but the series of transactions. So it will just see whether it will find out what's the proof value or the nonce value, and it will return the nonce value, right? So that's what the proof is. Now, how do you validate the proof, right? So validations of the proof, anyone when they receive the block, right? Like I mentioned, the miners will find out, and the first miner, whoever identifies it, will start broadcasting this block. So when a block is received, then what you will do is you will verify whether the previous hash value is correct, and you will verify whether the new hash value meets your difficulty challenge exit. Basically, whether the last trailing zeros are basically the last 4, in this case 4 digits, are zeros or not. So that's what we are just validating. So this is a very simple validate proof functions, right? So this is a function for validating. Any questions? Okay, so so probably what I will do, so if you just think, yes, go ahead.
Yeah, my question is, when do we create new block?
Okay, so there are two criterias or two factors that help you, that will trigger the new block creations. So let me just go back. right? So one, as I said, the transaction keeps coming into the network, right? So you will have a capacity of your block. Let's say your block size is let's say 64K bits, right? So in that case, and you know that your transactions, each transactions is, let's say, 1K bits, right? So in that case, you know that when you reach 64 transactions, when you'll receive 64 transactions, then that means you're now ready for creating a block, right? So that is the one conditions, because usually your transaction sizes are fixed and your block sizes are fixed. So you know the minimum number of transactions, sorry, the maximum number of transactions that will fit into that block. So that's one criteria when you will initiate a new block creations, right? Now, the second criteria is basically within a particular timestamp, because you cannot wait. Let's say no one performs, let's say everyone are busy watching World Cup, right? And no one is doing any transactions. So in that case, if there are one or two people who do the transactions, then they have to wait indefinitely until 64 transactions happens, right? So that is not a feasible solution. So the second criteria which they use is a timeout period, right? So the time difference between the new block and the last block, now they have a set time. It could be, let's say, 5 minutes, it could be a few seconds, etc. Again, depends on your blockchain configurations. So either it reaches the maximum transactions or it reaches a timeout period. In that case, whenever there is any transaction, let's say there is only 2 transactions within that 5-minute block timeout period. In that case, only those 2 transactions would be entered into the block, and then the remaining entities will be made null, and then you will trigger the block creation. Hope that answers your question.
Yes, thank you.
Any other question?
So one doubt.
Yes.
Is there any limitations for number of blocks in a blockchain?
No.
Okay,
It
sir.
depends. It depends on your block number, right? So again, I'll just go back. So how many bits? Yeah. So basically, in a blockchain, like I said, your block sizes are usually fixed, right? Your maximum blocks are fixed based on different criterias. So what you do is you usually allocate certain number of bits to your block number, right? So your block size depends on the number of bits you have reserved for that block numbering.
Okay, sir. If suppose the block number crossed that bit, whether the blockchain has started from the initial number.
Yeah, again, that depends on the implementation of the blockchain technology. So usually what they do is they will circle back, right? Rather than stopping that transaction, they will circle back. The block number will again then go back to 0. Usually what they do is they reserve a additional flag somewhere saying that this is an extensions for that particular thing. So there might be a what you call a minor update in the structure of the block. And then you can continue from 0, or they will not allow you to basically they'll say that this is the max you can number of transactions and you have reached that. So that's the typical 2 strategies approach. Usually they follow the first one, where they add a flag to indicate that this is a next chain for that
Okay,
particular
then
block.
only we can store every transaction from beginning now. So otherwise we will lose the information.
No, you will still have, right? So basically you're not storing every transactions. Basically what you'll have is, like I mentioned, it is a chain of blocks.
Oh.
So for you as a node where you're interacting with the blockchain network, you don't have to store all the transactions, right? So it is the responsibility. There are again, there are different roles in the nodes, right? One is the miner role. The other one is basically to cache all the transactions, or all the blocks, not transactions, all the blocks, right? So there should be a way for you to recover, traverse the block to confirm a particular transaction or to confirm if some tampering has happened, right? So again, traversing the blockchain is another concept or another discussions where each node, there will be a certain roles where these nodes will have to mandatory cache at least 20% or 30% of the blocks in the blockchain network, so that overall in the network, assuming that they're always available, these nodes are not going down, you will be able to recreate the blockchain. So that's another practical challenge if you look at it. But like I said, there are nodes reserved, and there is rewards given to nodes which will cache these blockchains, and from you can retrieve those blocks from that by requesting those nodes to send you those blocks in the blockchain.
Oh, thank you, sir.
Hope I'm not confused you.
Yeah, sir. Thank you. One another question is like you have told us like miners will create a block, then that chain will get continued, and some other block chain will get discontinued, no, sir.
Yes.
Like that you told. So if so, if suppose the miners who are make the block, that miners blockchain is getting continued, so the previous blockchain will get discontinued, means whether the transaction details will go out, otherwise how it will be, sir? All the chains will have all the transaction
That's
details or
correct,
something?
right? So that's a very good question. So probably I'll clarify it. So let's say you are at this point, this is your last chain, right? Or the last block. Now there are 20 transactions which has come, right? Let's say your block, let's say it's not timeout. Let's say you can have only 20 transactions for you to create block, right? So we are assuming that the miners are always in the network, right? So basically those 20 transactions will be in block A and will also be in block B, right? This, as I said, there's 20 unconfirmed transactions, right? So you will use that to trigger creations of a new block. Again, like I answered in the previous question, if let's say a miner A doesn't get all the 20 transactions, so then he will wait for the 21st transaction to come. Let's say he has dropped one transaction for some reasons, so he'll wait for the 21st transaction to come in that case, block B, let's say he starts the computing the nonce value earlier, so he'll be able to create the block faster or earlier, so that way his block will get accepted and block B will get rejected. So what I'm saying is a very valid question and a doubt, where at any given point of time, right, we are assuming that everyone is listening for these unconfirmed transactions because it gets broadcasted, and the miners would be using these unconfirmed transactions, right? So the one who is able to generate the block will ensure that all the transactions which he has received will get committed as part of that block, right? So even block A will, for example, even block A will use the same unconfirmed transactions. Block B also will use the same unconfirmed transactions, right? Let's say both of them have not lost any message or any transactions. In that case, whichever is faster, that blocks will get entered. Now, let's say that block A has lost one transaction. So in that case, he will the miner of block A would get delayed because he'll wait for either the timeout or for the additional transaction to come in place so that his block gets filled. So the moment the block A miner is delayed, so that means block B will be faster or quicker in delivering or creating or generating this new block. Hence, his block will get added into the blockchain. Right. Hope that answers your question. Or
Yes. But the thing is, after the 20 transaction, that block is getting added, right? That is the duty of miner, is that
that's
right,
correct.
sir?
That's correct. So once this 20 transactions happens, then what the miner will do, miner B will clear out these 20 transactions from his cache, and then he will start listening for new transactions, right? The moment this block gets broadcasted, let's say the miner block A or miner block C who are mining, they will see that someone has already created a block with those 20 transactions. So they will also flush their unconfirmed transaction pool, and they will reset it to, they will just delete, or they will start from the 21st transaction to start caching or pulling the 21st transaction, because they've already found that 20 transactions in block B. So that's how they update their unconfirmed transactions.
Thank you so much, sir.
Good morning, sir. In case of database, we do have control of what records are stored in a database. Here, every record is a transaction and it is being stored in a random block. Am I correct, sir? Or can we have control of grouping similar transactions in a block? In which case, how do we retrieve the record from the block?
Again, a very good question, right? A very valid, excellent question, if I might say, right? So usually what we do in blockchain is we will not group similar transactions in a block, right? Because then you'll run into complexities of if there are 20 transactions from me, and if you're waiting just for me to make those 20 transactions, I might do the transactions today and I might do the transactions 10 days later or 1 year later. So we can't keep caching these transactions, right? So that is where when you and I are in the same blockchain network, whether irrespective of my transactions, your transactions, anyone else transactions, we will try and pool so that we maintain the time order of those transactions, right? The time order of these transactions are very, very critical, right? And hence, it is not recommended, and usually blockchain may not be the right technology for us to store related transactions, right? Now that leads to a problem, like you rightly said, in relational database. Since you're doing the transactions in a particular table, you will be able to query faster and basically get the values or associated transactions related to you or related to someone else in a much faster way. Whereas in blockchain, like I mentioned earlier in the previous question, there are certain designated nodes which are responsible for managing and maintaining those transactions, right? As of those blocks, right? Now, if you have to query whether this particular transactions or this particular it's basically a set of transactions which has happened from an account B, you have to go and basically search every chain and then basically identify all the unique transactions which has been initiated by you, right? It's a very time consuming activities. So typically what they do, right? In the transactions, when you record the transactions, it is just not, sorry, I think I'll just go back to the, yeah. So when you're recording the transactions, I have kept this very simple, right? I'm having sender, I'm having recipient, and I'm having amount, right? So usually in Bitcoin, I'll just take the example of Bitcoin. What they do is they store the end state, right? So what they do is when I'm doing a transaction operations of debiting my account by 5, they will say that my end account, right? The account balance of sender is 70, account balance of recipient is 80. Right? So that is the information they store, so that you have to, when you're doing the next transactions, you don't have to traverse the blockchain frequently. You can just use the end state which is there, because this end state has been verified, validated, and authorized, right? Now that is where they store that end state. So that is the design of your transactions, right? Now coming to your second part of the question, saying if I have to know what type of transactions, how many transactions I have made, then the answer is yes. It is a very tedious process of navigating through the blockchain and basically identifying a state where which is your start state, and then looking at all the transactions originated by those senders and recipients, and then creating the destination state. So that is that's a very tedious process, and there are that's where there are a lot of smart algorithms, analytics coming on top of blockchain for so that they will do these analysis and keep these informations offhand, so that when someone queries, right, when you want to know what all transactions I did for the last 6 months, you don't have to always traverse through the chain. So you will cache this information and keep it. So that's an analytics which runs what we call as blockchain analytics. Hope that answers.
Sure, sir. Thank you. And another clarification, sir, whether we it is advisable to use blockchain where we need to store transactions alone. That is only certain fields. In case of records, say we are going to create a blockchain for maintaining faculty database. So in that case, say 5-year data, or I want to maintain the permanent database. So every faculty will be having so many proofs as appointment orders or attending certificates. So for such applications, is blockchain advisable? Because for land records, it is said that we can use blockchain. So in that case, there will be number of files associated. So in case the file is being stored, again, the retrieval process will take time. And also, where will the file be stored? Is it again a transaction?
Okay, again, a good question. So probably I'll split this question into two parts, madam. So first one is whether it is always necessary for me to store the file or the records, right? Let's say we are talking about the land records, right? It could be a scanned PDF or it could be an electronic document, or the certifications. Let's say if you're talking about faculty, what certificates, what certifications they have undergone, right, etc. So should I store that in the block itself? So usually it is depends on the block size. So typically, for example, let's say I'm working for a company where we deal with constructions, real estates, right? So we do these 3D models, right, or the BIM, the blueprints, what you call, right? So what usually we do is the blueprints are stored in a separate blob store or a large file store, right? Because these are gigabytes of file size. So if I put gigabytes of file in a block, that will become very challenging. So what I do is I store the file in a separate unique locations. Let's talk about it in one of the storage, let's say whether it is Amazon, Google, or Azure, Microsoft Azure storage blob store. I store that. I can take the URL, right? URL is the identifier how I can access that particular block, and the checksum of the block, right? So checksum is the value where it will ensure that no one has tampered that data. And I can store, instead of storing the entire file in the transactions, I can just store the URL and the checksum associated with the block, right? So that now my blockchain doesn't become huge or doesn't grow exponentially, but then I need to store somewhere centrally that large block files, right? Whether it's 1 GB, 10 MB, or whatever that file is. So that's the first part of the question. I think, hope I've answered that. Now coming to the second question, saying that whether blockchain is meant for transactional data, absolutely yes, right? So blockchain is a technology for transactions, right? Let's talk about transactions. We're talking about sensor. We want to know whether your, let's say we're talking about home control, right? We want to know whether Alexa has placed an order to refill your fridge, right? You want to store that saying that Alexa has ordered bananas at this point of time, let's say 1 p.m., right? Alexa has ordered apples at 2 p.m., right? So I'm just taking a home example. Or Alexa has asked this fan to be switched on at this point of time, right? So all of these are transactions, and for us to ensure that it is a genuine operation or a genuine transaction, and that's where blockchain comes in, right? So not just for land records, if you want to say that whether the faculty or whether the students have entered the campus, or they've gone out of campus, they've gone to library, they have gone to wherever recreation activities, sports center, etc. All of these are transactions, and your blockchain is the one which will ensure the trustness of this transactions, right? Now, if you are familiar with the database architecture, so usually you have a separate database for transactions, right? And you have separate database for analytics, and that's what your data warehousing tools perform, right? So that is what, so if you're doing any transactional operations, then blockchain is the right. Again, you might have to look at whether whether it makes sense, whether you have different untrusted networks. If there are untrusted networks in the transactions, then blockchain is the right technology choice for that transaction, right? And once you have committed those transactions, like I said, there are many blockchain analytics companies coming up, startups coming up these days. What these companies do is basically what they do, they extract the analytical information from these transactions, and then they create a analytical data warehouse where all these transactions, whatever is of interest, whether the end state, whether the transition points, etc., all of that information would then be stored in an analytical platform, right? Usually, if you're using ERP, then SAP HANA is one such analytical platform. Or if you're using any business intelligence, right, any of these analytical warehouse, Tableaus, etc., where you run 6 months transactions. Like you want to say, let's say for faculties, you want to know what is the last in the last 6 months, how many certifications have a faculty done, how many students have they guided, etc. So if you want to do some different things, so based on what your analytical requirements are, then you will create your analytical data warehouse, and then the analytical data warehouse will pull the intelligence or information from your blockchain blockchain transactions or technologies, and then generate those, give you those, maintain those analytical information so that you can run queries on them. I hope that answers your question.
Thank you, sir. Thank you for clarifying it. Thank you again.
Good morning, sir.
Good morning, ma'am.
When we select a miner, how to solve a complex mathematical puzzle, sir? Is it necessary to solve it?
Yes, like I mentioned, madam, the complexity, the difficulty to compute is one of the things which brings in the trust or the uniqueness in the block, right? So in this case, in proof of work, as I mentioned, it is all about the nonce value. I think I'll just go back. I talked about in proof of work, what you do is the miner's job is to identify this nonce such that the first 4 digits of the hash value is 0, right? So this 4 digits is the complexity. So you can make it 8 digits, then the time to compute the nonce will increase. If you make it 1 digit, then the time to compute the nonce will decrease. Now, let's say that you want to completely, let's say you eliminate the complexity at all, right? So you don't care what this hash value is. In that case, then what happens is anyone can go ahead, commit these transactions, right? And there'll not be any validation mechanisms to say that this person, this block is genuine or not. So in that case, like I mentioned, in the private blockchain network or in community blockchain networks, what you will do is you might say that my difficulty of hash could be 0. Like I don't have to check for trailing zeros, but then what I will do is I'll check for whether it's an authorized miner who has computed this, etc. Right? So you will add other parameters. So you have to decide on what you choose as your difficulty, right? Whether you want to waste the compute power by generating nonce, or the algorithms, write a complex algorithm to generate nonce, or you just want to use a trusted list of miners, and then you make them in a round robin mechanism, say that miner A will be the first one to create the first block, then miner B will create the block, etc. So you so basically you will have to add the additional complexities or additional mechanisms to govern these miners. So that will be the complexity. So in this case, for public network, to overcome this governance of these miners, they have just used this complexity or the difficulty of the hash values as one of the mechanisms to bring in the trustworthiness of the transactions. Hope that answers.
Yes, sir. Yes. Thank you, sir. I have one more question, sir.
Yes.
Regarding healthcare, so what kind of data can be stored inside the blockchain, sir?
So I think regarding the healthcare, it could be there are multiple things, right? So let's talk about as an individual, you want to store your medical records, right? So basically, one way is from a consumer-focused way. You can store when you consumed your medicines, what type of medicines, when did you purchase, when did you refill your medical medical stocks, transactions as an individual, where we are giving you, or the blockchain application is giving you and enabling you to live a healthy life and ensure that if you're chronic disease, let's say you're a diabetic patient, right, and you need to ensure that you have tablets or these diabetic shots every day. So that way you can provide, or you can use blockchain to manage and track the chronic illness and help the patients to cope up with this chronic illness, right? That's the first one use case which I can think of. The second use case is for the hospitals or for the transaction records per se, right? So basically today, if you look at one of the biggest challenge, and this is, I think there are a few startups working on this idea. If you look at today's biggest challenges, you will go to Dr. A, he will do a diagnosis. After 6 months, you may not go back to the Dr. A. Let's say you are traveling, or you're in a different location, different city, etc. So then you will go to Dr. B. Dr. B doesn't have access to your records, right? So, and you don't usually carry your medical records everywhere, wherever you go, right? In case of emergency, right? So the second one is basically accessibility of the medical records, where you need to ensure the secrecy or the basically privacy of the medical records, and but still be able to access, basically the doctor should be able to access your medical history, right? So usually when you go and get admitted to the hospital, or when you go to an hospital, they'll say, do you have these in the past 1 year, 3 years, did you face these type of symptoms, etc. So instead of depending on your opinions, now what they can do is they can put these type of transactions, your diagnosis, in a blockchain. They can secure it. They can still make it safe so that no one else can access it. But then when there is an emergency, when there is an accident or something, they can easily access all your past history of what diagnosis you have gone through, etc., so that they don't have to redo some of the checks. So especially if you look at an emergency cases, the first 1 hour is very, very critical for your patient's survival, right? And usually in that 1 hour, people typically waste time doing blood checks to say whether what blood group it is, whether he has few predefined illness, etc., right? So you can avoid these basic checks if you have access to an authentic diagnosis or medical history of a person. And that is where a lot of startups in US are currently working on creating what they call it as a vault, right? Medical record vault using blockchain, so that when there is an emergency, you don't have to carry around or call someone to say, can you just look at these certificates, what is that, etc. So you have all your medical records, diagnosis digitized. That's the second basically applications where we have seen the adoptions or increased adoptions of blockchain. The third one is basically your hospital management, right? So usually whether it is Max or Vocard, etc., these hospitals have usual large networks. So managing the day-to-day transactions or operations of the hospitals, whether the hospitals are clean, whether the number of staffs are doing their jobs, whether any action is pending, etc., right? So all the hospital asset management is another area where we have seen, at least I have seen, the use of applications of blockchain.
Thank you, sir. And my last question, I should use only SHA 256, or I can go for any other algorithm for hashing, sir?
You can use any other algorithm. SHA 512 is now becoming popular, right? So basically it depends. We have just given an example here of SHA 256 because at that point of time, I think 5 years back, that was the popular one. I think these days most of the blockchain technologies support multiple hashing algorithms, so you can pick whichever algorithms of your choice.
Yes, sir. Yes, sir. Thank you so much, sir.
Thank you. So, Kavishankar sir, I'm not sure how much time is left. Do you have 5 minutes to just wrap up? 2 minutes? Can I take 2 minutes to wrap up?
Hello,
Sorry.
one more question, sir.
Yeah, go ahead.
Sir, I'm the research scholar of PSG. I sir want to blockchain in the RTO system. Can we help me, sir? How can we implement?
When you say RTO, which aspect of RTO? Because RTO has so many things. Any particular area within RTO you're looking at?
When the RC is transferred from one person to another person, there is a many contributors in the middle of the end. They can very corruption is there in that aspect and any other aspect.
Sure. I think a very good question and topic which you're looking at. I'm not sure if you have looked at this concept in US called as Blue Book of a car, right? So basically, like you have the RC book in India, there is a concept of Blue Book in US where all your transactions, right? Who's the owner? When was this service done? Was there an accident records of a car? Because usually selling and buying cars is a very tedious and a very tough challenge, and especially in India, buying and selling cars. I think these days there are also misuse or terrorist use of cars, etc. So that is where what you can do is you can make car as your central transaction or focus of transactions, and all aspects or transactions associated with the car, with the owner of the car, the service levels of the car, the accident histories of the car, all of this can be stored in blockchain because like you rightly said, there are multiple parties. Your insurance companies are there, your owners are there, your RTO, which city it is registered, where was the transfer of registrations, etc., and the presence, the distance traveled by the cars, the maintenance frequencies, etc. All of that can be represented as a blockchain, and you can write your own smart contract just for managing your the Blue Book for your particular car or vehicles, right? So yes, that's a very good topic.
Any papers are available is in this topic?
On the car, I have not come across, because I think I've not seen, because there is so much of regulatory intervention, so I've not seen this as a use case. So that way it could be a good one. So probably let me just also see if there are any papers associated with that. But as far as I recall, I don't think I have seen for tracking and managing. There has been few startups which has been grappling with this idea, but I don't think they've got any funding, at least when we broached about 2 years back. I don't see anyone else getting the funding for this. But yeah, I don't know about the research. Sorry, to just be very frank.
Okay, sir. I think it is a fresh topic.
Yeah, that's a good topic. Yeah, interesting application.
Okay, sir. Thank you, sir.
Sir, is there any difference between zero knowledge proof or proof of work?
Zero knowledge proof. Can you just explain me that? And can you just elaborate that a little more?
Zero, like proof of stake and proof of work, another concept is called zero knowledge proof. It's an algorithm.
Yes.
Whether proof of work and zero knowledge proof are same or different?
No, they're different. So I think probably. So like I said, right, proof of stake is a zero knowledge of work type of an example, right? So that's what, like I said, you have different algorithms, right? So proof of work is not the only algorithms, or when you're talking about zero knowledge proof, is basically you're talking about that there is no, it's a negative of proof of work, right? So I think that's a different concept.
Okay, sir. Since you have spoken about IoT sensors data, one thing is I'm having like a doubt, like in sensors data also is like whether the sense data are just directly stored in blockchain, or whether, like you said, whether the data are stored, transactions are stored in analytics, and then analytical tool is used for what are the futures that we are selecting to be stored in block in a block.
Okay, so let me probably correct here. So the transactions are stored in the blockchain, right? The analytics aspect is basically the summary of those transactions would be then computed, traversed, and then created whatever information is required in your analytical system, right? So now let's talk about sensors, right? So you're saying that, let's say you have installed a weather station in your campus, right, in your college. Now, when the weather station tells that the temperature has now changed from 27 degrees, I don't know what the current temperature in Chennai is, but let's say that it is changing from 27 to 30 degrees, right? So when this change happens, this is a transaction, right? So the weather station can say that, hey, record a transaction in the blockchain saying that now the temperature has changed from 27 to 30 degrees, and this is what and my weather station ID is XYZ, right? So that is a transaction which will get showed, which will get pushed to your blockchain, right? Now, in that case, because if you do a proof of work, then the time it takes to confirm these transactions are very, very high. So hence, what they do is they either go with proof of stake or proof of authority, because in this case, I don't have to, I have basically, you can call them as zero knowledge proof, because you're not proving that you have done a work, right? Whereas you're just doing it that you have the authority to create that block or create that transaction. So that's what you typically do, and that is what you so basically that's what gets recorded in the transaction. And blocks for the analysis. Sorry, let's say you want to know what was the last 7 days deviations in the temperature. Weighted average transactions, sorry, you store the weighted average temperatures in a different database, because what you do is you traverse through the database, you validate, you aggregate, you average out the data and store it in the warehouse, and then you use your analytical tools like your Tableaus, ClickView, etc. to generate the reports. Hope that clarifies.
Yes, sir. Thank you, sir.
Sir, I have one more question, sir, to you. Thank you for your patience.
Your voice is too feeble. Can you speak closer to the mic, speaker,
Yes, sir.
please?
Now, yes, sir. Now you can able to audible.
No, I think it's still very far
Any
away.
more question is there?
Sir, is
Yes,
this
madam.
audible,
Hmm.
sir?
Yeah, go ahead. I'll try and attempt to understand.
Yes, sir. Yes, sir.
Ma'am, your
Regarding
volume is
you
low,
talk
ma'am. Bit loud, ma'am, please.
yeah, now is it okay, sir? I don't know why.
Go ahead, madam. Yeah.
Uh, yes, sir. No, actually, in the blockchain, you talk about still about the secure, I mean, the trustable, the transactions, but still we have facing the blockchain itself so many security issues like phishing attacks and then routing attacks, like 51 percentage attacks, like so many attacks. For example, as per my research, what I'm going to do, I'm going to use in the blockchain technology also. How I can secure the networks using the blockchain technology? You have any idea related that?
That's a evolving research area, and like any other technology, there are always people who wants to break the technology, right? There are cyber attacks, people who will always try and see how they can break this technology so that the technology can be made fail proof. So you're absolutely right? The 51% attack where especially in the private net, sorry, in the public network, the 51% network attack is one of the big challenge, and hence the concept of proof of authority or proof of stakes or this public or community based blockchain. So there are different alternatives depending on the type of attack, right? So
Yeah,
that's
even
an
we can say
evolving.
the minus itself may be the intruder. Attackers may come into the attackers who solving the puzzles. So minus itself who adding the block. The miner itself may be the attackers. So how we can solve this kind of issues? Is there any effective algorithm we can Is there already?
No, madam. I think if you're asking for a one-stop shop or algorithm or a mechanism to prevent this, the answer is right now we have not identified a mechanism or algorithms to prevent, let's say, or if you're, I think you're referring to the 51% attack, right? So especially in public networks, it is very, very difficult for us to identify and prevent the 51% attack. Like I said, the alternatives could be going into a community-based blockchain where you could have proof of authorities, right? I think Byzantine fault tolerance is another mechanism. So there are evolving algorithms, but none of them have achieved or have resolved this particular attack. So if you're looking at a research topic, this could again be a good topic, but you need to be aware that there have been multiple people and multiple alternatives which people have proposed to counter these attacks, but I don't think we have standardized, or we have one algorithm beats all others or is superior to other algorithms. So there are multiple alternatives which are existing. May not just be for proof of work, but again, there are different alternatives which we might have to evaluate. But this could be a very good research paper. If you're doing your PhD, then this could be your literature reviews to summarize all the different alternatives to overcome the 50% attack. So that's a real good research paper you can publish.
Thank you, sir. Then one more thing, is it possible to add any intelligent kind of like machine learning? We can able to integrate with blockchain and machine learning algorithm. Is it because we can classify what are all the attacks and then what are all the normal? We can able to classify before the. Is it possible, sir, integrate with machine learning and then in the blockchain technology?
I think.
Prevent the
Yeah, I think a very good question, and that is the current research trends of using AI in your blockchain, right? So artificial intelligence or machine learning to identify or to enable the consensus, etc. So I think yes, I think that's currently, I think in the last 2 years, the focus have picked up of applications of AI has been.
Thank you, sir. Thank
Thank you, everyone. Kavi sir, anything?
They have asked for your email ID. I will be sharing that with you, with them, in case. Sir, they have asked for your email ID, sir. I can share that.
Sure.
Them. No, sir.
Sure. I think you can reach out to me at this email. I think it is there in the slide.
Yes. Sir, thank you very much, sir, for the wonderful presentation, and also see whatever the queries that is being asked by the participants, it's been addressed very well. Yes. Thank you, sir. Thank you very much, sir.
Thank you all. Please feel free to reach out to me.